everybody. This is Bob Kim, School of Finance, Sungsil University, Seoul, Korea. This is lecture for finance students using financial calculator. We are using Texas Instruments BA2 Plus to explain different concepts of time value money and then teach you how to use a financial calculator. Okay, this lecture is a lecture for slide 5. We are discussing uneven cash flow streams. All of cash flow stream we discussed so far, including ordinary annuity and annuity due, we're dealing with the situation where the equal periodic payment occur every period. So we discussed the three common components so that the particular cash flow to be considered as annuity. However, for this type of cash flow, also called uneven cash flow stream, the payments occur each period are not identical or equal. So simply, it cannot be considered as a payment at all. So uneven cash flow situation. As you can see from the timeline here, we have 100 at t equals 0 and 200 is in a row until t equals 4, and at t equals 5 we have a 0. Okay, so those payment or those cash flow rather, t equals 1 through t equals 4 are identical and they are all $200, and then t equals 6 we have 1,000. So those cash flows are not equal. That's why we cannot use the payment function key in your calculator. We cannot consider them as payments. Okay, that's the definition of uneven cash flow stream situation. Let's go ahead and use BA2 Plus. We need to go to cash flow register to register all those cash flow on this timeline. Cash flow key is in the left hand side here. So as soon as you hit the F key, let me go ahead and hit it again. Key, okay, you have a CF0. Okay, as you can see from the screen, the cash flow register already contains some cash flow, which may be the information you already used to solve a previous question. The first thing you need to do is you want to clear or resetting cash flow register. How you can do it? You're using the second function, so-called clear work. Okay. Second function clear work can be performed by pressing second key and CE/C key. So as soon as you hit second followed by CE/C, you perform clear work here. Okay. And then as a result, you will have all numbers at equal to 0. Now you should be ready to enter the cash flow you have above. So t equals 0, you will have 100, and you hit enter key to enter those $100. And then now you're going to use down arrow key, 01, the first cash flow on the timeline, not the first one in this case, because C01 is first cash flow in the future. But here, the first cash flow on the timeline is not 200, must be 100. But this is occur at the present time. Okay, so you will enter CF0. This is the present time cash flow. Okay, but if you move up to the C01, go up to the C01, that's the cash flow in the future. So the first cash flow in the future should be 200. Okay, enter and go down. Then 01 is a frequency of first cash flow, C01, but we need to pay attention to that cash flow frequency indicating how many times C01 occurred on the timeline in a row. As you can see, the $200 occur on timeline 4 times in a row, so you enter 4. Okay, next cash flow 0, so enter down, frequency 1, only one time, and the next cash flow 3, 1000, enter, go down, it's 1. So you just enter all those 7 cash flow. Okay, even though there are 7, you only enter 100, 100, 0, and 1000. Why? Because you can use frequency function or frequency key to enter $200, right? Now you need to go to the MPB here, MPB, and as soon as you press MPB key, it's showing you need to enter I. So I here is an input. You should remember I as input 6%. Okay, and go down. So you have a compute indicator here, so that simply you can pressing compute. So 1497.9817 should be the answer. Okay. So the calculator, you should know how to use a CF register, the cash flow register, to handle uneven cash flow streams. So what about the future cash flow? Okay. So which means 1497 is a present value here of all those 7 cash flow. Now the question is finding future value here, t equals 7, okay? And you simply use this as a present value, okay? It is a 7, okay? And the interest rate is a 6%, okay? No payment, because you already consider the present value of all those cash flow stream on this line. So you should consider payment must be 0. Compute future value. So 2252.4106. That can be the future value of this cash flow stream, uneven cash flow stream. Okay. And the second material from this slide is compounding period. The material we discussed so far has not specifically mentioned what is a period or the length of period. But from now on, you need to pay attention to what is the actual length of periods you're calculating. There are many ways of telling the compounding period. Most common type of length of period is year. So annual compounding. Interest is compounded once a year. So if you look at the present value of 100, period rate is 6%. In this case, there should be annual rate of return 6%. 23, so 3 years. And the future value 119.1 must be the future value of present value 100 3 years later when the annual rate is 6%. So as soon as I mention what is the length of each period, now the question becomes more realistic. However, if you think interest is compounded twice a year, so 6 months per period, then the present value is minus 100, and then the period rate is not 6% anymore because it is compounded twice a year. So 6% divided 2 is 3%. So semi-annual compounding means each period the interest compounded by 3%. Okay, and also number of period is not 3 years anymore. So twice a year, so there will be a 6th period. Okay, so let me go ahead and try these two calculations to show you how the difference of compounding period make difference in your time value of money calculation. So go to the calculator first, clear time value money. Okay, now I'll start from the left hand side to the right. So NA3, interest rate is 6%, present value 100, obviously minus. There should be an investment, so cash outflow. The compute future value 19.1016. However, if the question becomes semi-annual compounding, like the second example here, so n should be 3 times 2, which is equals to 6, and interest rate, annual rate is 6% twice a year, so divided by 2 become 3%. If you change the n and the periodic rate, because compounding period has been changed, then you must have a different future value, which is 119.4052. Obviously, there are many different frequency of compounding, quarterly, monthly, daily, and etc. Calculation must be done using the period rate and number of period. Even though what is the actual length of period, when you're using calculator, you only focus on what is the period rate. Okay, obviously, the exact length of period can be different, but you only focused on the period rate and number of period, not the stated or quoted or nominal rates, and the number of years. If you don't change C/U or C/Y setting, and we mentioned that we're not going to change that setting at all, so we only focused on, again, what is the periodic rate and number of period. Okay. However, when you interpret your calculation outcome, you have to pay attention to what is the actual length of period. That's why you can understand what is happening in realistic situation. Different compounding periods are used for different types of investment. Bank account daily and dividend annually, and etc. As we shown from those two exercises above, A and B, period rate must be stated rate or API or quoted rate. which is annual rate, divided by number of payment per year. That makes periodic rate. By the same token, the number of period must be number of years times periods per year. Okay, please do this exercise, and probably you should understand what we're trying to explain on this. Okay. The last topic on this slide is amortized loan. When you get a loan from a financial institution, auto loans or mortgage loan or student loan, etc., you borrow money from the financial institutions as a lump sum, and you promise to pay back as a series of periodic payments. The loan is paid in equal periodic payments. Okay, so let's look at this example. Probably you have a better understanding after you solve this exercise. The total or lump sum amount today is 1,000. Okay, after you got $1,000 from the bank, let's say, probably you do use that $1,000 to utilize it. Maybe you can buy a mountain bike. Maybe you can buy a nice CD player, whatever. And then you promise to pay back to the bank in a predetermined periods, in this case 3 years, as a form of annual payment. Interest is 6%. The first thing you need to do is finding payments. Okay, go to the calculator, so clear time value of money, and looking at those 5 keys, and then here a 3 period. Okay, because annual payment and the number of years should be 3, so in this case a 3 period. Interest rate for each year is 6%. The current amount or present amount you borrow today is $1,000, so it's a positive amount, and you're going to pay back to the bank as a form of annual payment. $374.10, approximately 11 cents, is annual payment at the end of each year. Okay, so the problem here you should understand is amortization schedule at your payments of 374 is a sum of interest and repayment principal. Let's look at the first year. You borrow $1,000 and you pay back 374.11. But among $374.11, not all of them are interest, not repayments of principal, or neither. So out of 1,000, you only pay interest $60. Why? Because interest is 6%. So out of 374, $60 is interest payments, and remaining 314.11 is repayments principal. Since the repayment principal for the first payment is 314, you still have $685.89 as a balance. Okay, the ending balance of the first year becomes the beginning balance of the second year. Obviously, is basically same time, and then you make a payment. Okay, you pay the interest on 185, which is 41.15, and you pay 474.11, and the interest is 41.15. So repayment of principal is 332.96. So how much is remains as a balance? 352. Okay, you can do the same thing for the year 3. Okay, so after 3 payments for 3 years, your loan will be fully paid. Okay, let's take a look at this table and let's see if we can get this number from the calculator. So one thing you need to do is using amortization. So where is amortization? Second function of amortization is a present value key. If you look at the present value key, you have AMORT, which is nothing but amortization. So what you need to do is the second present value key. So be careful of P1. Okay, P1 is a starting point. Starting point is here. Okay, then you enter 1. Okay, even though it's already 1. Go down to P2. The P2 is ending point. Suppose starting first period and over the end of first period, then P2 is also 1. Okay, go down, you see the balance. Okay, this balance right here, and go down minus 314. This is repayment principal. ARN indicating principal, and then you hit the down arrow key once more, you will see the payment of the interest. Okay, so by hitting P1 is 1 and P2 is 1, you can see all those numbers on the first row of the table. Okay, let's say P2 is 2 and the P1 is 2, then you can see the second row. But interesting case is 1 is 1 and P2 is 3. Okay, so starting is 1 and then ending is 3, so that you see the cumulative number of this repayment principal and then accumulate number of interest payments. So go down, balance is 0. Obviously, it should be 0 here. And the principal 1,000, this number right here. So which means the loan must be fully paid. Accumulation of interest is 22.32. So you have all these numbers from the table. Again, to understand what is going on amortization loan, you may need to do a little bit of exercise. Thank you very much. This is the end of our discussion on slide 5.